Welcome back to the show, everyone. Remember our last deep dive, the one all about the JavaScript event loop?
Yeah, how JavaScript juggles all those tasks like a pro.
Right. Well, get this. Today, we're going even deeper.
Deeper. How is that even possible?
We're diving into how to keep your JavaScript code running smoothly even when things go wrong. Error handling and debugging.
Error handling and debugging. Those are essential for building any reliable application. You know what, though? It's not just for the experts. It's for everyone.
I like the sound of that. Makes my code more resilient, user-friendly. Sign me up. But where do we even start? What kinds of errors can we run into in the JavaScript world?
Well, you can think of them in three main categories.
Yeah.
First, you've got your syntax errors.
Syntax errors, those are like the grammar police of coding, right?
Yeah, exactly. Like
Wow.
typos in your code. They prevent your code from even running.
Okay, so like what? A missing parenthesis?
A missing parenthesis,
Yeah.
yep. Or, a misspelled keyword, like trying to speak a sentence with missing words.
Mm-hmm.
It just doesn't make sense.
It just won't work.
Won't work. Then you've got runtime errors.
Runtime errors, those sound more dramatic.
They happen in the heat of the moment. During the execution of your code, it causes the program to just stop.
Oh no. Can you give me an example?
Sure. Imagine you're trying to access a variable that hasn't been defined yet.
Sure.
You're asking JavaScript to find something that doesn't exist. So what does it do? It throws what's called a reference error.
A reference error, so it just freaks out.
It freaks out because it doesn't know what to do.
Okay, got it.
Uh,
So syntax errors, those are like typos. Runtime errors, like hitting a poor wall. What about that third kind you mentioned? Logical errors.
yes. Logical errors. Those are the sneakiest ones.
Why are they so sneaky?
Because your code will run without any complaints, no errors, but it just doesn't produce the result you expected.
Ugh, the worst kind. Can you give me an example?
Imagine you have a function that's supposed to add two numbers, but you've accidentally written it to subtract them instead.
Oh no. The code works perfectly, but the answer is just plain wrong.
Wrong. A real headache to debug.
Sounds like it. So we've got all these different types of errors lurking in our code, but there's got to be a way to handle them, right? We can't have our applications crashing every time something goes wrong.
You're absolutely right. You can't have that. That's where this amazing thing comes in, called try.catch.
Try.catch. Fill me in.
It's like a safety net for your code. You can handle those runtime errors gracefully and prevent your entire application from crashing.
Ooh.
It's like a two-part system. You've got the try block, where you put the code that might cause an error. And then you have the catch block, which, well, catches any errors that happen in that try block.
Okay, so if there's an error in the try block, it just gets tossed over to the catch block.
Talked right over.
What happens in the catch block?
Instead of the whole program crashing, you get to decide how you want to respond to that specific error.
Oh, cool.
You can log the error. You could display a nice message to the user.
Like, hey, something went wrong.
Yeah. And in some cases, you might even be able to recover from the error completely.
Wow, so try.catch, it gives us control. That's especially important, when we're thinking about the user's experience, right?
Totally.
Oh.
Imagine if every little hiccup on a website made the whole thing crash. It would be so frustrating.
I wouldn't use that website.
But try.catch. It handles those errors smoothly in the background, keeps the user informed, and, keeps the whole application running smoothly.
It's like a shield. But wait, something tells me there's a catch. We shouldn't just wrap all of our code in try.catch blocks, right?
You're catching on.
Yeah.
Try.catch is powerful, but it's not a magical fix-all solution.
How so? More safety nets. That's always a good thing, right?
Not always. Think of it this way. If you have a leaky faucet, do you just keep mopping up the water and ignore the leak?
No, you fix the leak.
Exactly. Try.catch, it helps you manage the errors, but you got to find the root of the problem.
I get it. If I'm constantly catching errors but never fixing the underlying issues, I'm just sweeping problems under the rug.
Yeah, could lead to even bigger headaches down the road.
Right. Gotta fix that leaky faucet. So try.catch is great for handling those unavoidable errors, but we gotta be smart and write clean code in the first place.
Absolutely. And to make things even easier, we can create custom errors.
Custom errors! We get to make our own.
Our very own. Because sometimes those default JavaScript error messages are a bit too generic, especially in big, complex applications.
Right.
With custom errors, we can provide more information about what went wrong and where. It makes debugging much easier.
So it's like leaving a note for yourself.
Yes, a trail of breadcrumbs.
Give me an example.
Let's say you have a function that divides two numbers. Basic stuff. But we all know you can't divide by zero, right?
Yeah.
You could create a custom error to check for that. and then throw a very specific error message.
Okay, like, hold on, you can't divide by 0.
Right. Much more helpful than some vague generic message.
Oh, yeah, definitely. So we're basically anticipating potential problems and saying, nope, not going to let that happen.
Exactly.
Yeah.
And you can use custom errors for tons of things. Validating user input, handling specific business logic, any situation where you need to give more helpful feedback when something goes wrong.
That's super helpful. Okay, so we've got try.catch to handle errors gracefully. And now we're creating custom errors to make them super informative. Anything else?
One more trick up our sleeve. The finally block.
Finally. Okay, now I'm intrigued.
It's the unsung hero of error handling.
How so?
The finally block ensures that certain code will always run no matter what. Error or no error.
Okay.
It's all about guaranteed execution.
I see.
Think of it like this. You've got a function that opens a connection to a database. You always want to make sure that connection is closed.
Oh, right.
Even if an error happens somewhere along the way.
Makes sense.
The finally block, perfect for that.
So even if something goes wrong, the finally block swoops in and closes the connection. No loose ends.
Exactly. It's like a cleanup crew.
Nice. Finally, you've earned your place in my toolbox. Okay. So we're handling errors like pros now, but we also need to be able to actually find those errors.
True. And debugging can feel like searching for a needle in a haystack sometimes.
Ugh, tell me about it.
But good news. We have some amazing tools to help us out. And your best friend here, the browser's developer console.
Oh, the developer console, my go-to.
Like having X-ray vision. One of the most basic but powerful tools in there is console.log.
Oh, I use console.log all the time.
A classic for a reason. It lets you print values, variables, messages to the console so you can actually see what's happening in your code.
Super helpful for checking if a variable is what I think it is, or to see the flow of the code.
Exactly. And you know what? Console.log has some siblings.
Siblings?
Yep. Like console.warn for displaying warnings and console.error for, well, highlighting errors.
Handy, so it's easier to see what's going on.
Much easier.
Yeah.
So console.log and its crew are great for getting the big picture. But sometimes you want to slow things down, right?
Yeah.
Examine things closely.
Yeah, like frame-by-frame analysis.
That's where breakpoints come in. In Chrome DevTools, you can actually set breakpoints in your code. They pause the execution at specific lines.
So you can freeze time.
Freeze time, like hitting the pause button on a movie. You can examine variables, step through the code line by line.
Super helpful.
Oh, and the DevTools interface. You can actually step through your code one line at a time.
That's so cool. So it's like having slow motion replay of our code.
Exactly. We can catch those little subtle errors that might slip through the cracks.
Nice. Anything else in our DevTools arsenal?
The call stack. It's super helpful. It basically shows you the sequence of function calls that led to a particular point in your code.
So if an error happens deep down in a bunch of nested functions, the call stack can help me unravel it.
Exactly. It's like a map showing you the path your code took to get to where it is.
Okay, this is all making so much sense. But wait, we've been talking about the browser's developer console, and earlier you mentioned VS Code.
All right.
Are there any good debugging features in VS Code?
Absolutely. VS Code has an amazing built-in debugger. It's like having the Chrome DevTools, but inside your code editor.
The best of both worlds.
Yep. You can set breakpoints, step through your code, inspect variables, all without leaving VS Code.
So it's got everything I need.
It's super convenient, especially for bigger projects.
Mm-hmm.
Okay, so we've covered a lot of ground here. Different types of errors, try.catch, all those cool debugging tools. But how does all of this work with asynchronous JavaScript? All the callbacks, promises, and such.
Yeah, that's a great question. I mean, asynchronous code can be a bit of a wild ride.
You're telling me. Debugging asynchronous code, that can be tricky. But the good news is, many of the principles and tools we've talked about, they still apply.
That's a relief. But I am curious to learn more about how to tackle those challenges. I have a feeling that promises and this thing you called async await are going to be key players here.
You're right on the money. Promises and async await. They're essential tools for managing all that complexity in asynchronous JavaScript.
Well, I'm all ears. Let's jump right in and explore them in our next part. Okay, so we're back and ready to tackle this asynchronous JavaScript. It can feel a bit like the Wild West out there. Callbacks, promises, everything happening at its own pace.
I hear you. It's definitely got its own unique set of challenges, but a lot of the error handling and debugging techniques we've talked about, they'll still come in handy.
Okay, that's good to know. So what are some of those challenges then? What makes debugging asynchronous code trickier?
Well, one of the biggest things is that errors might not show up right away.
What do you mean?
Remember, asynchronous operations, they happen in the background. So an error that happens in a callback or maybe inside a promise, it might not actually cause a problem until much later.
Oh, so it's like a delay reaction.
Yeah, exactly. And that can make it tough to figure out where things went wrong.
Right, because by the time you see the error, the code has moved on.
Exactly. It's like a detective case, trying to trace back the steps.
So we need to be extra careful. Any tips for debugging in this asynchronous world?
Well, first things first, you got to understand how asynchronous operations actually work in JavaScript. You know, like how they affect the flow of your code.
So understanding the basics is key.
Definitely. And then good old console.log is still your friend. Put some logging statements in those callbacks and promises.
Ah, so you can see what's happening at each step.
Yep. It's like leaving yourself a trail of breadcrumbs. And breakpoints, those are still super helpful too. But now you'll want to step into those asynchronous callbacks and promises to see what's going on behind the scenes.
So we're not just stepping through the main part of the code anymore.
Nope. We're stepping into the asynchronous world.
I see, I see. But besides debugging, are there ways to prevent these errors in the first place? Especially when we're dealing with asynchronous code.
You're thinking ahead. That's great. And yes, there are things you can do. One of the most important is validating any data that you get back from those asynchronous operations, like from API requests.
Oh, right, because you don't have control over what that API sends back.
Exactly. So you need to have some checks in place, make sure the data is what you're expecting.
And what if it's not?
Well, then you can handle it appropriately. You know, tools like Postman or Insomnia can be really helpful for testing those API requests.
Okay, so we're being extra careful with what we let into our code. What else can we do?
It's also a good practice to handle potential errors within those callbacks or promises themselves, not just relying on a higher level try.catch.
So we're catching errors at the source.
Yeah, like having multiple lines of defense, it makes your code much more robust.
I'm liking this, but I have to admit I'm really eager to dive into promises and this asynchronous stuff.
I heard you. They're game changers for sure, especially when it comes to writing asynchronous code that's actually readable.
Well, let's not waste any more time. Fill me in. What are promises all about? They always seemed a bit mysterious to me.
They can seem that way at first, but they're not that complicated. A promise is basically an object that represents the eventual result of an asynchronous operation.
So it's like, I promise to give you a value later.
Exactly. It's an IOU for a value that'll be available in the future once that operation is done.
Okay, that makes sense. But how do we actually use promises in our code?
Well, think of it like this. A promise goes through three main stages. First, there's pending.
Okay, pending, like it's still working on it.
Yep. Then there's fulfilled. That's when the operation succeeds.
It delivers on its promise.
Right. And it carries a value with it, the result of that operation. But then there's also rejected. That's if the operation fails.
Oh, no.
And it carries an error object so you know what went wrong.
Gotcha. So pending, fulfilled, or rejected. But how do we actually work with these states in our code?
That's where these awesome methods come in.
Yeah.
Then, .catch, and finally.
That sounds familiar.
Well, they're kind of like event listeners for promises.
So we're telling a promise, hey, when you're fulfilled, do this. When you're rejected, do that.
You got it. The then method is called when the promise is fulfilled, and it gets the value.
Okay.
The .catch method is called when it's rejected, and it gets the error object.
So we can handle it.
And just like before, the finally method, it's always called no matter what.
So we can do some final cleanup.
Yep. This structure makes promises super powerful for managing these asynchronous flows, especially when you've got multiple operations that depend on each other.
It's like a choose-your-own-adventure for asynchronous operations.
That's a great way to think about it. But I know talking about pending and fulfilled states, it can sound abstract. Let's look at an example.
Okay, that would be helpful.
Remember our fetch data function. We can rewrite it using promises. It would look something like this.
Sure.
We still use fetch to make the API request, but now it returns a promise. And then we use this chain of .then and .catch methods to handle those different outcomes.
So the first, that takes the response and parses it as JSON.
Right. And the second .then, that's where you'd actually work with that data. And then .catch is there to gracefully handle any errors.
Okay, it's all coming together. But you mentioned earlier that there's this thing called Asynchronous. It can make all of this even simpler.
Ah, yes. Async await. This is where promises really shine. It's like syntactic sugar, makes your code look and feel so much more like regular synchronous code.
Syntactic sugar, so it's like dot sweeter to work with.
Exactly. It's all about readability and elegance. So to use async await, you first need to declare a function as, well, async. This basically signals to JavaScript, hey, this function is going to have some asynchronous stuff going on. And then inside that async function, you can use the await keyword before a promise.
So async sets the stage, and then await is where the magic happens.
Exactly. The await keyword is like saying, hold on, we need to wait for this promise to settle before we move on.
So it pauses the execution.
Pauses it. And the best part, your code will read like it's all happening in order, even though those asynchronous operations are still doing their thing in the background.
That's so cool. I need to see this in action. Can we see that fetch data function with this async await magic?
Absolutely. It would look something like this.
Wow, that's way cleaner. All those .then and .catch chains, they're gone. Now it just looks like a regular try.catch block.
I know, right? And that familiarity makes it so much easier to work with. Async await, it brings order to this asynchronous world, makes it easier to understand, easier to debug.
I'm already a fan. So where would we use this in real life? Give me some examples.
Oh, there are tons. Like, imagine you need to make several API requests that depend on each other.
That happens all the time.
With async await, you can write the code in a way that just flows naturally.
So no more messy nested callback.
No more messy callbacks. It's like writing a story, There's a beginning, a middle, and an end, even though those asynchronous events are happening behind the scenes.
This is amazing. We're bringing order to the chaos. But I'm guessing there are some things we need to watch out for, right? With async await.
You're sharp. It can be a bit of a double-edged sword. It simplifies things on the surface, but you need to really understand how it works under the hood.
Okay, I'm ready to dig deeper. What do we need to watch out for? Welcome back to the show.
So last time, we got a glimpse of this async await magic and how it can make promises so much easier to work with.
Yeah, it's pretty amazing. It can really change the way you think about writing asynchronous JavaScript.
I'm ready to dive in. Remind me again, what makes async await so special? Why are developers so excited about it?
Well, you know how promises are all about representing the eventual result of an asynchronous operation? Async await takes that idea and makes it even better.
Okay.
It gives you a way to work with those promises that's just more intuitive.
More intuitive, like easier to read and understand.
Exactly. You can write asynchronous code that looks and feels more like the synchronous code you're used to.
Oh, that would be a game changer. So how does it actually work?
Okay, so first, you got to declare a function as async. That tells JavaScript that this function is going to be handling asynchronous operations. And then inside that async function, you can use the await keyword right before a promise.
So async sets the stage, and await is where the action happens, right? Await is like saying, hold on, pause everything. We need to wait for this promise to finish before we move on.
So it literally pauses the execution of the code.
It does. While it's waiting, the JavaScript engine can go off and do other things, keep the app running smoothly. And then once the promise is settled, whether it's fulfilled or rejected, the await keyword basically says, okay, we're good to go, continue.
I see. So it's like we're creating this illusion of synchronous code, even though under the hood, it's still all asynchronous.
Exactly. That's the beauty of it. And it makes the code so much easier to read and understand.
I'm starting to get it. But you did mention earlier that async await can be a bit of a double-edged sword. What are some of those potential downsides we should be aware of?
Well, one thing is, it's easy to forget that await can only be used inside an async function.
Oh, right.
If you try to use it in a regular function, you'll get an error, and your code won't run.
Okay, good to know. So we need to make sure we're in the right context.
Always. Another thing to watch out for is performance. Await pauses the execution, right? So if you use it too much or in the wrong way, it can actually make your code slower.
Ah, so there's a trade-off there.
Yeah. There are ways to use await more efficiently. Like if you have several promises that are independent of each other, you can use promise.all. It lets you resolve them in parallel instead of waiting for each one individually.
So it's like saying, hey, you promises, go do your thing. I'll wait for you all at the finish line.
Exactly. That can speed things up quite a bit.
Yeah.
Okay, so we've talked about how to use async await and some of the things to watch out for. But what about debugging? Are there any specific techniques that are helpful when working with async await code?
That's a great question. I'm all ears.
Well, good news. Breakpoints and stepping, they work even better with async await.
Even better. How so?
Because your code reads like a synchronous flow, you can just set breakpoints within your async functions and step through the code. It's like debugging synchronous code, even though those asynchronous operations are happening in the background.
Wow, so it simplifies the debugging process as well.
Yep. And of course, console.log, that's still your best friend for understanding what's happening in those asynchronous flows.
It's amazing how many of the techniques we learned for synchronous code still apply when we're working with asynchronous code, thanks to Async Await.
Exactly. It's all about adapting those tools to this new landscape. Well, I think that wraps up our deep dive into error handling, debugging, and the wonderful world of asynchronous JavaScript.
This has been an incredible journey. I feel like I've learned so much.
I'm glad to hear that. And to all our listeners out there, remember, keep practicing, keep experimenting, and never stop learning. The world of JavaScript is constantly evolving, so there's always something new to discover.
Well said. So to all our listeners, keep coding, stay curious, and we'll see